Okay, section 3.6 is going to deal specifically with perpendicular lines. And so before we get too far into it, I want to draw a little picture and have you think about something. So let's say you have a person and they're standing somewhere and there's a wall out in front of them, right? So here's my person, here's the wall. And if you asked, or if the question was asked, how far away is the wall? Right? So let's say that you see this scenario and somebody says, hey, how far is the wall? Well, from where the person's standing, I don't think anybody would measure like this, right? Nobody would do that. I think everybody would measure like this. And without knowing it, you're recognizing that the shortest distance from something to a line is the perpendicular distance. And so you wouldn't actually do this, right? So we cross that one out. You wouldn't do that. So what this little picture is representing is that the shortest distance from a point to a line is the perpendicular distance. Okay, so that's a big idea. That's an important thing to think about. And hopefully that little picture will help you all, help it click in your head a little bit. So in this same area, I'm going to draw another picture. This is going to be a triangle. So here's going to be a line A, C. Call it line A, C. And we're going to put a point out here. This will be point P. So if we're measuring from point P to line AC, we're not going to measure from P to A, and we're not going to measure from P to C. We're going to measure from P to B, which is not a point that we had on the line, so we're going to add it if we have to. And we're going to always make the measurement be the perpendicular distance from the point to the line. And so we're going to write down a little note here is we may not be able to find out how long segment PA or segment PC actually is, but they'll always be longer than segment PB. Okay, so go ahead and write that down and just think about that for a minute. If we had a triangle that looked like this and we wanted to know how long segment PA was, well, we may not be able to figure it out. But if we knew that segment PB was, say, 5, well, we know that this one has got to be longer than 5 because it's farther, right? It's a farther distance. So keep that in mind when we're doing these problems with perpendicular lines. And we're going to do a quick example of how that works. So we're going to draw a line, and we're going to draw a triangle off of it. So this will be point C, point A, and then we'll go back up to point B, and this is going to be a right angle. So in our problem, we may know that this is 12, and we know that this is x minus 5. And your instructions will say, write and solve an inequality for x. What that means is you're going to write down and solve a greater than less than problem to find out what x could be. So if we look over here at this line, BA, right? Well, I don't know how long it is, but I know that it's got to be less than 12, right? So I'm going to say x minus 5 has got to be less than 12, right? It has to be, because from A to B is the perpendicular distance, and that's the shortest distance. So A to C has to be longer. But something else that I'm going to say, and this is more for you to think about than worry about too much, is x minus 5 has to also be greater than 0, right? Because you can't have a line that's 0 long or -2 long. So this x minus 5, while you might say, oh, that could be any number, well, it really can't. It's got to be bigger than 0, and it's got to be less than 12. So the way we'll figure this out is we're going to solve these two inequalities at one time. So we're going to look at this like this is two equations, two inequalities, but we're going to do it all at once. So we're going to add 5 here, which means we add 5 to this side and add 5 to this side. And so we're going to get that 5 is less than x, which is less than 17. And the way you read this is you would say x is between 5 and 17. So it can't equal 5 and it can't equal 17, but it can be any number between 5 and 17, and that would work for our picture here. So this is your answer. This is how you would say it. Okay, so that was just a little quick one. Don't worry too much about it if it was confusing. We'll practice it. All right, we're going to write down a theorem. Perpendicular lines theorem. All right, and it says that if two intersecting lines so we have two lines and they intersect, if they form a linear pair of congruent right angles, then the lines are perpendicular. Perpendicular. Right? So if we see two lines, right? They intersect. And when they intersect, they form a linear pair that's both right angles, right? So you see two right angles side by side. Then those lines are perpendicular, okay? So if this is line R and line S, we would say R is perpendicular to S. All right, so we write down two more now. Now this one doesn't have a name, but we're going to learn a way to write it really short, real shorthand way to write it. But first we're going to write it long. So if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line. Okay, so it might sound like common sense, but we're going to draw a little picture of it. So let's say we have two parallel lines, because that's what it's talking about here. And we have a transversal that cuts through them like this. And it is perpendicular to one of those lines. So now remember, parallel, I would need to mark them with the little parallel symbols. So when we have two parallel lines and another line is perpendicular to one of them, well, hopefully it makes sense to you that it's going to be perpendicular to both of the lines, right? So we're going to just do like that real quick and give you a little picture. So when you see it perpendicular to one, that implies that it's perpendicular to both. And the shorthand way to write this, when you have to use it in one of our proofs, is to say that if we're perpendicular to one parallel line, then it's perpendicular to the other. Okay, so that's kind of your little shorthand way to do it. So it's perpendicular to one parallel line, it's perpendicular to the other. Last one. If two lines are perpendicular to the same line, then the two lines are parallel to each other. All right, so quick example. We have two lines perpendicular to the same line, right? So our two lines here are perpendicular to this vertical line. Well, that means that those two lines are parallel to each other. Hopefully that makes sense. If they're both perpendicular to this line, that means they both have the same slope, so they're both parallel to each other. And the way we could shorthand abbreviate that is to say two lines perpendicular to the same line implies those two lines are parallel. Okay, so these two things we're going to use in some proofs, and this is just a quick shorthand way you can write down what you're trying to say, because there's not a name for them. The first one we did called the perpendicular lines theorem, so it's got a name. You can just say the name of it. But the other two, you got to kind of write. You're supposed to write them all the way out, but I'd be fine if you just write something like this, and it'll make sense to me. All right, that's it.